Hi, I'm doing Paul McWhorter's Pico W lessons and I'm up to lesson number 98, which is continuing to control the servo using PIO. And this week Paul wanted us to be able to sweep the servo arm from 1 degree to another. So typically it's from 0 degrees to 180 and back again. Now before I show my solution, I just want to say that if anyone comments on my videos, I try to reply, but recently it hasn't been working, so I write a reply, it shows up in Studio, but the comment count doesn't go up, and then it doesn't appear on the video. So if you don't get a reply from me, it isn't because I'm being rude, it is actually because YouTube hates me, but there's nothing new there then. So this is my program. It's very similar. Well, it's based on my solution to lesson number 97. But before, all the setup that I was doing, I did up there between lines 12 and lines 13. But I decided to move it down here outside. So I'm doing a put and a pull and execs and everything like that. And the reason why I did that is so that the number of instructions, I can keep the number of instructions in that state machine to 8 or less. And if you can do that, then you can fit 4 state machines on one PIO block, which is a good idea, especially for using servos, because you might want to be using a lot of servos. So come down here. So initially I set the angle to 180 just to put it in a nice start position, and I call set servo on the angle. All that does is it converts the angle to the pulse width, and then it puts it, and I do an exec pull. Simple. Then in the while true loop, I've just got 4 loops. It goes from 0 to 180, sets the servo, sleeps for a bit, and then from 180 back to 0, I'm doing the same thing. So we'll run it just to make sure it works. Apologies for my breadboard setup and wires. It's kind of about as bad as it normally is. I should have made this faster. I just want to prove that it does work. Doobie-doobie-doo. Will it turn round? Hurrah, it's turned round. It works. But, there's always a but. I don't like that. It's completely blocking. And if you put something in the for loop, it would get your timing out. And if you, it's just horrendous, because what else can this program do apart from move the servo, which is pretty lame. So I thought to myself, there are other ways of doing it. Now, one way is I'm using a potentiometer, and instead of the 4 angle equals 0 to 180, etc, 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 I'm just reading the potentiometer, and then there's a little sleep there, but that is just to stop the potentiometer blowing up or whatever. So we'll run this. Right, it goes to where it was. So I can use the potentiometer, and yes, I can make it sweep. But if I really want to make it sweep and go on sweeping, I have to sit here twiddling the potentiometer. But I just wanted to show that that is possible, and it isn't blocking, but it isn't ideal. That isn't really what we wanted to do. So I thought could use a timer, but I think there's a limited number of timers that you can have, and you might want more servos than you are allowed timers. It could be 7, I'm not sure, might be less than that. And then I thought you could use async IO, but that means changing the structure of the program a lot. Ideally, you should be able to do it within, I'm looking at the wrong program, oh no, it doesn't matter, that's all the same. You could do it in there, but I don't want to get too ahead of myself, or too ahead of Paul's lessons, because that's what happened with the PIO challenge, and I got bored. So I'm taking it slowly this time. So ideally it will be done in there, and it would be so much easier if you had an X, Y and a Z register, but that wouldn't be much of a challenge. Or you could use generators. Now, I love generators. I did a video on generators. I'll leave a link to it. It was my solution to lesson number 55. I don't know how many people liked it, don't know how many people watched it, but if you want to learn, I'm not going to explain what generators do in here. I'm in the wrong one. Right, here. So to stop it blocking, I want to get rid of that for loop, that sleep, that for loop, and that sleep. So if you kind of remember what that looks like, we'll go over to the generator program. And here is my generator, and it's got the same for angle in blah blah, and instead of setting the servo angle, it yields the angle, and then it isn't blocking because the for loop is within the generator, which is quite handy, and there's no sleep either. So that generator will just give you the first angle, and then it will wait for you to go back and ask for the next one, ask for the next one, ask for the next one. I'm not explaining very well, but you have to watch my other video if you're vaguely interested. Then in the while true loop, I'm setting it up so that it checks to see whether it's time to move the servo, and if it is, it will move the servo. So it says hello, hello, the sweep delay is 5. Has it been going on for 5 since the last time? Yup. Then it will go set the servo to the next angle from the generator. And that's brilliant because you can put in another servo and it could have a different delay time. And of course it could be going from different angles, it could be doing all sorts of things. So I think that's pretty good because it completely gets rid of the delay and blocking. So we'll try running this and hope it works. And I made it the same speed. So it looked the same, I made it the same speed, but I bet you and I are all wishing it was a little bit faster. We'll just see whether it turns round. Yeah, it turns round. So we'll stop that program. So that's my solution. It won't be my final solution because hopefully I will be able to do it within the state machine itself. But that's my video, and I hope you liked it.